Okay, let's get started here. Girls, I'm going to go through 6.3. I'm going to start with that today. And then able to finish 6.2?
Not completely.
Okay. All right, that's fine. I'm just going to start 6.3 and then I'll answer questions from 6.2. And I posted the answers to that assignment on, so maybe we can look at that this morning as well. Okay. So first thing we're going to look at this morning is adding and subtracting rational expressions. So basically, again, like I said yesterday, we're basically when we're talking about rational expressions, we're talking about fractions. So I need to know how to get a common denominator, of course, okay? And one of the ways in which we get a common denominator, if the first way is we say, okay, what do both 2 and 3 go into? So that's my lowest common multiple. What do they both go into? They both go into 6. The other way I can do it is, it may not be my lowest one, but it'll always work, is if I took 2 and I times it by 3. That would also get me to my common denominator, okay? So one of the ways, this is where it gets confusing when it comes to rational expressions. So I'm going to try and do this the best I can. So I obviously want 6 as my common denominator between 2 and 3. So what do I multiply 2 by to get there, to get to 6? Well, I multiply it by 3. Whatever I do to the bottom, I have to do to the top. And then right here, I multiply it by 2 over 2. So what that gives me is 3 plus 2, which is 5 over 6. Now that's fine. We've done that a number of times. I mean, we learned how to add fractions, grade 4 or 5 probably. So we'll do another one because I want to get this so that we have this really fresh in our mind when I start to look at polynomial expressions. So let's take 3/4 plus 1/5. So common denominator, well, the lowest common multiple I would get was 4 times 5, which is 20. So what do I times 4 by to get to 20? 5. What do I multiply 5 by? 4. So that gives me 15 plus 4 over 20, which is 19 over 20. Okay? And that is basically just adding rational expressions together, rational numbers together, which are essentially just fractions. So today, we're going to apply this same concept to rational expressions. So the first one I'm going to look at is on page 253. And actually, sorry. How do I want to do this? Well, I'm going to start with this, and then I'm going to start with the way I would normally do this, and then I'm going to show you what they're doing, and I'll use working example 2 after. Okay, anyways, I have 2x plus 4 over x squared minus 9, add 7x, subtract 10 over x squared, subtract 9. So I already have my common denominator. My common denominator is x squared, subtract 9. Now what I would do is I'm going to just simply collect my like terms. 2x and 7x make 9x. 4 subtract 10 makes negative 6. All right? Now, that's no problem there. That's all there is to it. But again, because I have variables on the bottom of a fraction, I also have to worry about my non-permissible values. So my non-permissible values in this case is x can't equal plus minus 3. All right, x squared equals 9. Square root of x, or square root of 9 is 3 and negative 3. So that's all there is to it. That one, I already had my common denominator. Let's look at B. So again, I'm on page 253. I'm looking at 1B. So I've got 10A plus 5. Oh, you subtract this time. Now, subtract 3A, subtract 2. See that subtract sign? I'm going to add brackets here because I have to trigger my mind to the fact that that negative is going to be both for the 3A and the negative 2. Okay? So I go 10A, subtract 3A, 7A. 5, subtract the negative 2 is plus 7. All right? I have that subtract changes this to a negative. That subtract changes that to a positive. So 5 and 2 make 7. And A can't equal 0. And B can't also equal 0. So far, so good. Hopefully this is coming across to you all right. I've got a couple technical issues this morning. Okay, so no problem here. Common denominator was already given to us. You simply add your top or subtract your top terms, your numerators, and you end up with your solution. Okay, now the next thing is to, they show a different way, a different method to find a common denominator. And I actually like this method a fair bit. And they basically use bubbles for it, all right? Or circles, whatever you want to call them, ovals. So what we do is we draw them out. I'm going to use B as my example first. I'm going to skip working example 2A, and I'm going to just use B as my example. And although it's not much better. Yeah, it's not much better. Let's start with A. Okay, so I have this 1 over 2x, 1 over 3x, and 1 over y. So I have 3 expressions. That means I have 3 denominators. So I'm going to send up three circles. And I'm going to compare the denominators. So this is denominator number 1, this is denominator number 2, and this is denominator number 3. And what I'm trying to do is trying to find out what is the common denominator between them. Now, if I was looking at this right now, I know 2 and 3 make 6, so 6 has to be a part of my common denominator. I see I have an x here and an x here. That's got to be a part of the common denominator, and I have a y here. Also part of the common denominator. So the way they do it here is they take, all right, denominator number 1. What do both of them have? They both have an x. So I put that in the joining one. Also has a 2, and this has a 3. So there's denominator number 1. Denominator number 2 and denominator number 3. Neither one has anything in common there, right? So I have a y down here. I already have the 3 here, and I have the x there. Okay? So again, this may seem a lot more confusing to you, but we'll try it anyways. And then denominator 1 versus 3 is 2x and a y. So I already have the 2x and I have the y. So now what I do is once I see that I have all of these, I simply multiply them to come up with what the common denominator is. So my common denominator for this expression would be 6xy. 2 times x times 3 times y. Now I mentioned that earlier. 2 and 3, common denominator between them is obviously 6. We both have an x, so the x has to be in there, and the y has to also go in there. So this is just simply another method in which you break down your denominators in order to get a common denominator. Okay? Let's look at the second one here. I have Okay, so the first method I would go like this. And I'm going to show you both methods. You can decide what you like and what you don't. The first method I do is I put down every single term underneath one time. All right, so I have x plus 5. That's got to be a part of my denominator. I have x minus 4. Has to be a part of my denominator. And x plus 7 has to be a part of my denominator. So based on just that, this is what I feel like my denominator is going to look like. Okay? Now, if we add squared values in there, that might change things a little bit. But this is what my denominator, I think, is going to end up looking like. Using the Venn diagram style of bubbles. So I've got denominator 1, denominator 2, denominator number 3. So in the middle goes what is common in both. So looking at denominator 1 and denominator 2, they both have an x plus 5. That goes right there. Denominator 2 has an x minus 4. All right? What's common between D2 and D3 is x minus 4. So I'm going to move that x minus 4 to right here. I don't need it up here anymore. Okay? I stick it in the middle between them. And then down here I have x plus 7. Because I don't want to repeat it. I don't want to repeat that. All right? And then the common denominator between this guy and this guy is x plus 5, x minus 4, x plus 7. So they're all there. So just by comparing the two, that's how I end up with x plus 5, x minus 4, x plus 7, which is what I began with in the first place. Okay? So this is kind of a visual learning one. All right? You might see it better. Those of you that have pretty good algebra skills just have to recognize, you know, what do all of them have? All right? We need one of each in order to do this. Now, the reason we're doing this is, again, we have to add fractions, but our fractions are going to contain rational expressions. All right? Now, the last one, it gives us, in C, it gives us x squared plus 6x plus 9 and x squared plus 8x plus 15. So, again, the first thing that I would do in this is I would simply factor first. So I'm going to change it to this. So x squared plus 6x plus 9 is x plus 3 times x plus 3. And then I have x plus 3, x plus 5. All right. So now this is a little different. Okay? So I've factored it down, and I see that I have x plus 3 in both, but this one I have an extra x plus 3. We have to recognize that. And this one I have an x plus 5. So I'll start with bubbles, because for this one, it may make more sense. All right, what do both of them have? Both have an x plus 3. But this one has an extra x plus 3, and this one has an x plus 5. So my common denominator now can be written as x plus 3, x plus 3, x plus 5, or that x squared, x plus 3 squared, because there's two of them, x plus 5. For the visual learners, this actually works better when you only have two denominators to work with. Okay? All right. Now, once we've established how to find the denominator, we then have to figure out how do I add them together once I have the denominator. That's the next step. All right. So let's have a look here. Again, non-permissible values have to be written out. So I write those out first. Well, the first thing I do is I factor, and then I write my non-permissibles. But this one's already been factored. Okay, so how I would look at this question, myself personally, I look at it and I say, okay, I'm going to put my line down here. And the first thing I'm going to do is I'm going to write down what I think the common denominator is. And again, you can do it whatever way you want. But I'm looking at this. This has an x and x plus 1. This has an x plus 1. So I think that I write down everything one time. So x times x plus 1. All right. Now, this guy right now already has the correct common denominator. So I don't have to do anything to x minus 15. I can leave it like that. All right? This guy, when I compare it to this denominator, what is it that x plus 1 is missing on the bottom? Well, it's missing an x. So what I need to do then is times the top and bottom by x. So I get this. So then that becomes x minus 4 times x. I take that x and I times it by x minus 4. X times x plus 1 gives me what I want on the bottom in terms of my denominator. Now, I distribute through and I simplify it as best I can. So I've got x minus 15 plus x squared subtract 4x all over x and x add 1. Collect my like terms. I've got x squared. That's minus 3x minus 15 over x. That's x plus 1. Okay? Now, if it was possible to factor this, I might do that. But if it's not factorable, I leave it as is. So my solution for this is x squared subtract 3x subtract 15 over x times x plus 1. X can equal negative 1 and 0. All right? So again, I look at my denominator with what I started with showing you today, and I basically say to myself, okay, I'm going to, once it's factored, I'm going to write out every term and put it on the bottom. Just the same as when I was doing 1/2 and 1/3. I multiplied the 2 by 3 and the 3 by 2. So it basically is 2 times 3. That's what it was. I do the same thing here. Okay? Let's look at a second example here. So I have 6x over x minus 5. Minus 240. Again, I like to factor right away. Make sure I factored correctly. Looks like I did. And for the record, the one way I know I factored correctly in this particular case is because my non-permissible values match what I've written here. Okay? So now, I look at this. What's my common denominator? Well, this has an x minus 5. That also has an x minus 5 and an x plus 3. So my common denominator here is x minus 5 times x plus 3. And again, this is where I find some students struggle, is how I look at it is I say, okay, in order to get the common denominator here, what do I have to multiply this denominator by in order to make it look like that? Because whatever I do to it, I'm also going to do to the top. So in this case, it's times by x plus 3. And whatever I do to the bottom, I have to do to the top. So I have x plus 3 times x plus 3. So that gives me 6x times x plus 3 minus 240. Okay. So I have that right there. Now I want to see, is it possible to factor this? Well, I do see that I have a greatest common factor of 6. So I'll take it out first, and then let's see what I'm left with. X squared plus 3x minus 40. Now, when it comes to expressions, I have to leave all values in. I can't divide them completely out. I have to leave them all in. So at this point here, I got to look, is there factors of negative 40 that add to give me 3? And the answer is yes. So I go from here, I'm going to go up to there. So I've got 6, x on top. And the factors of negative 40 are plus 8 and negative 5. Okay, so I factored this. Plus 8 times negative 5 gives me a plus 3. Now, I actually cancel those out once I've factored it. So I'm left with this, 6x plus 8 over x plus 3. I like leaving brackets. It's not necessary, but I like leaving brackets on the bottom just to show that I think of it as a term. And that's that. So this would be your final answer right here. To comment on Amron's question yesterday, because the back of the book sometimes multiplies this through. I wouldn't multiply it through. I would leave it as is right there. All right. Now that basically covers adding and subtracting of rational expressions. Okay. The biggest thing is, number one, is being able to factor. That's huge. Factor your equations first. And then the second thing is find the common denominator. Once you've located what your common denominator is, I say to myself, okay, well, if this is the denominator, what is this guy missing from this? Well, I see that I have x minus 5s, but I don't have an x plus 3 here. So if I don't have an x plus 3 here, I have to multiply it by x plus 3. Okay? This one has both of those, so I don't need to even touch it. All right? And that basically takes care of all of that. Okay? All right, are there any questions about what I've done this morning so far? I know it's new, so there probably isn't. So how about we have a look back at yesterday's work first? So if you want to, if you have questions, you can unmute your mic, and I'll look at the questions from yesterday's 6.2. So do you have any questions from 6.2? I can't see any of you, so.
Good morning, Mr. Newton.
Hi, Austin.
I just have a quick question on page 247.
Yeah.
5B.
Okay. All right.
Please and thank you.
Yeah, no problem. Okay, so again, I'm not rewriting the question. What I'm doing is I'm already advancing. So the first thing that I do is I flip the second fraction. So I flipped it, and then I have to look at, is there anything that I can factor? Is there a greatest common factor? In this case, it was BC subtract B, so I factored a B out of it. All right, now for my non-permissibles, C can't equal 1. A can't equal 0. B can't equal 0. I also have to acknowledge the fact that that was a denominator to start with. All right? So at this point then, I am going to cancel top and bottom with whatever I can. So that's going to cancel like that. All right? Now, what am I left with? A squared times A. Well, that's A cubed, right? And then I have C minus 1 times C minus 1. I can write that as C minus 1 squared, and then I would end up writing out my non-permissibles. Now, does the back of the book cancel the C minus 1s?
I think they did it wrong, because when I did it, I got the same thing that you have.
Yeah.
But then I look at the back of the book, and their answer is AB squared.
Yeah. I think that's what's happened is if that was a multiplication, let's say it wasn't division, if it was multiplication, that's what you would end up with. All right, so the back of the book isn't right on this one. I know there's a couple examples in here that, or a couple of the questions in here that the back of the book we had a problem with. So that'd be one, this is one of them for sure. This is the correct answer for what's given in the book. Okay?
Okay, thank you.
No problem. Any other questions? Austin, do you have any while your mic is on?
No, I don't think so. Thank you. Sorry, I have to log here.
Okay, no worries. Anybody else on here have questions from yesterday's work?
Could we do 7B on page 249?
You bet. All right. So factoring wise, x squared plus 2x plus 1. So that's x and x. And the only factors of 1 are plus 1 and plus 1, right? Then on the bottom, I can't factor anything out. I'm left with 2x plus 1. Now I'm going to multiply it. So I'm going to change. I'm going to flip that next fraction. So I'm going to put x plus 10 on top. Okay? And then on the bottom, I have x times x minus 3. All right, I factored an x out of there. Does that make sense, Tessa?
Yeah.
Okay, and then I've got times. Okay, so now I'm going to show you the advanced way of doing this. Okay? The advanced way is this. I know that 2x squared, there is only two possibilities, 2x and x. And with 3, there's only two possibilities as well. 1 and 3. Excuse me, 1 and 3. And now I need to get a negative. So I go 1 and 3 like this. 2x times that is going to give me negative 6x. Add 1x, that's going to give me the negative 5x. So this is kind of the advanced.
Sherry, Calvert, call 15,000, please, Sherry.
This is kind of the advanced way of doing the factoring of this. Okay. If you wanted to, you could do the product. So the product would be negative 6, the sum would be negative 5, and then you have to do all the factors. So I'm just trying to cut down a little bit of the work. Okay, do you follow that, Tessa?
Yep.
Okay, so then x squared plus x becomes x times x plus 1. So far, so good?
Yeah.
Okay, so non-permissibles. Let's just do that for a second. So my non-permissible here is negative 1/2. Up here is negative 10. Down here is 0 plus 3, 0, and negative 1. So far, so good?
Yep.
All right. Now I just have to cancel. So let's go through and cancel anything that's on the top and on the bottom. So x plus 1, x plus 1. 2x plus 1, 2x plus 1. X minus 3, x minus 3. All right, and that's what I'm left with. So I'm left with, on the top, I have an x plus 1, an x plus 10. And on the bottom, I have x times x. That might be one I would just multiply. There's my final answer right there, comma, and then my non-permissibles. Okay? How did you make out with it? Where did you find your error?
Factoring.
Factoring. Yeah, that's what I expect. Was it this one? The 2x plus 1, x minus 3, was it that one that you had trouble factoring?
It was the last one that I messed up on.
Yeah, okay. All right, so that's, yeah, and then taking the greatest common factor out here as well. So those are the two I would expect the errors to end up being. And like I said, I did that last one. I did it the shortened way, but if you wanted to do it the long way, and your factors, so it would be negative 6 and 1. So I would go 2x squared minus 6x plus 1x, subtract 3, brackets, 2x out of here. More work, but that's still okay. All right, that's still all right to do it the long way and end up with that. Okay, and if you have binomials, meaning two terms, you're always looking for a greatest common factor, okay?
Okay.
All right. Do you have any other questions that you want to see?
Question 10 on 250.
Okay, the sphere is contained inside a rectangular box such that the sides of the sphere are touching the sides of the box. What fraction of the volume of the box does the sphere occupy? All right. Fraction of the volume of the box does the sphere occupy? Okay, so the side length for the box would be 2r, right? That would be the side length, because if the radius from the center of the circle to the outside of the box is r, the length of that one side would be twice that, right? Because it's basically the length of the diagonal, right? So the volume of the box then would be 2r times 2r times 2r, which is equal to 8r cubed. So far, so good?
Yeah.
And then it says, what fraction of the volume of the box does the sphere occupy? So I would divide that by 4/3 pi r cubed. I think should give you the fraction of it. So if I'm doing that, that pi stays on the bottom. 8 divided by 4/3. Let me just do that over here. So I'm at 8 divided by 4/3, which is equal to 8 times 3/4, which is equal to 6. Okay, that cancels into 2, so that's 6. Our cubes cancel, so I think it'll be 6/pi would be that. That's what fraction of it would be, but I'm not sure exactly. I think so.
It's pi over 6.
Is it pi over 6? What did I do wrong then? I got this upside down then right here. Sorry. Oh yeah, my bad. Okay, and I'll explain myself. Sorry, I did that wrong, Tessa, in it. 1 cent. If I'm trying to find the fraction of it, the total should go on the bottom, which would be 8r cubed here. The total should have gone on the bottom, and then the portion of it should have gone on top. So that was my fault. So I have that. Okay. So I have 4/3 pi r cubed divided by 8, which is equal to 4/3 times 1/8, right? So that's this. That equals to 6 on the bottom, like that. 1/6. So it takes pi over 6. Okay?
Okay.
Sorry about that. I made an error on that. All right. And that pretty much covers almost all of 6.2. Did everybody get the answers posted for the assignment yesterday?
Yes, I got them.
Okay. Was there
Yep.
any of them on there that you want me to do and explain a little bit better than you just looking at it?
Not for me.
Okay.
Yeah, I think I'm pretty good too.
You're okay? Good.
Same with me.
All right. So for you guys, it wasn't too bad because I had only 2 pages, but I was really finding it difficult to get. It's easy to get it out to you, but getting it back was a mess. I did it with the grade 10s, and I had a 5-page assignment, and it was just awful. I had pictures of different sizes. I couldn't print some stuff off. So what I'm going to try, I know, Austin, you went on that OneDrive yesterday just to see that you can get in. So now that I know you can get in, I'm going to use OneDrive to give you your assignments, and then you guys can dump them back into the OneDrive after you're done. Okay? So,
Like an app?
well, okay, so you know how you got into Microsoft Teams?
Yeah.
Okay? You do the same thing, except you go to OneDrive now. On the and then I have a folder for PreCalculus 30S, and I'm gonna dump one assignment into it tomorrow, and then we'll try it. I'm just trying to find the easiest way to make yours and my life simpler when it comes to doing all of this stuff that we have to do right now. Okay, so to me, that's the easiest way to attempt it, is to put it in this OneDrive. I was going to do Dropbox, but the division said to do OneDrive instead. So tomorrow, so right now you've got 6.2 and 6.3 to complete. And then we will, just let me see, is there 6.4?
Yeah.
This? Okay, I'll leave 6.4 for Monday. What I'll do is I'll put a sheet of questions out tomorrow, basically on 6.1 to, I'll give you a small assignment tomorrow to do for the weekend, and then hand it back in. And that one I'm going to try and mark, and then I'll mark them because I can scan them then, and then I can put them back in, or I'd have to email them to you. what I'll do is I'll just mark them. I'll put your marks on Edmodo, or sorry, not Edmodo, on Power School. And then you guys can check your own assignment. I'll put the answer key in Monday after I've got them all in. Okay. So the biggest thing is I'm going to need them done on the time that I do them. Otherwise, I can't mark them. So this is the only way I can kind of keep you honest in terms of getting the assignment in on time, and then you'll get your back to you, and then I can post the answers at that point. Okay?
Yeah.
Does anybody else have any questions or concerns? Are we okay with how we're doing this right now?
Yeah, so will the rest of the week,
What?
will the rest of the week just be answering questions?
Well,
Video chat?
I'll do 6-3 tomorrow. I'm going to go through another example or two tomorrow of 6-3 with you, because 6-3 is kind of the main one. And then I will, there's some problems on 6-3 that'll cause you some issues, so we may have to look at those tomorrow. There was one other thing. What the heck was the other thing I was going to talk about? Your time for class is going to switch next week. You're going to end up at the 9 o'clock session next week, which was your normal time anyways. I know it's no fun, but I think Mrs. Cowan has some of you for grade 11. I don't know if it's English, and she wants to do some work with you too, possibly. So she would like to start at 10:10. So I'm going to switch you guys up and put you at 9 next week. Okay?
Okay.
All right. If nobody has any other questions, then we should be good for today. All right.
Okay,